Now is the moment of keynote speech by Dr. Majid Gazor, an internationally renowned scientist and Al-Biruni expert. I am inviting Mr. Majid Gazor to deliver his speech.
Rahman Rahim. I'm asked to shorten my talk, so I will skip some of things that I have prepared to present. I'm also asked to translate a couple of slides of my presentation in Persian, so I have to shorten a little bit more of my stuff. I skip the thanks slides, things that I have prepared to thank the organizers. I follow the custom and quote a couple of statements from two renowned historians, as I see that the carefully worded statements from them actually presents my own personal opinion that says that one of the very greatest scientists of Islam and all considered one of the greatest of all times. His critical spirit, toleration, love of truth, and intellectual courage were almost without parallel in the medieval times. The other one is from Ghafarov. Biruni was so far ahead of his time that his most brilliant discoveries seemed incomprehensible to most of the scholars of his days. In my personal opinion, as a mathematician, actually I'm not expert in the history of mathematics. I'm basically a mathematician. And I just presenting my own personal understanding from a few of mathematical works of Al-Biruni and compared from my understanding of nowadays mathematicians. I try to answer the question that why do we need to study Biruni's mathematical works. I present how Al-Biruni found a way to estimate the radius of the Earth. I briefly present a famous and old problem of trisecting an angle and the mysteries that is behind this question. There are some stuff that he was the first person that understood the concept of functions and treat them. I will skip these. About some stuff that's related to accurately estimating roots of functions, that is the basis of the advanced numerical analysis and most engineering research today. Some plane projection that I will not go through that. There's a question that why do we need to study history? Many historians, they have many answers, but what I intend to say is that why do we need to study math works of Al-Biruni? Basically, his works has had a long impact on the rapid progress of mathematics. So by studying his work, we can understand what is the key players in his research work so that we would learn and do the same so that we would be able to contribute into mathematics. He was really a very professional researcher. His contributions from 1,000 years ago still is very has many lessons from modern researchers. He was aware of important ethics of rapid following the ethics of research that has a rapid impact on the rapid progress of science. What he was doing, he was trying to learn all the mathematics that has been done by all mathematicians, Indian, Greeks, Hindus, and he used to translate the mathematics that they have done in different languages. He was used to learn all the mathematics of different nationalities they have done, compare them, check if the results is correct or not. If it's not correct, correct them, modify them, criticize them, and improve their results. And what he was doing, he was not just doing research, he was not presenting what he was discovering, but also presenting other people's work, improving them, And that makes his contribution more important and more useful. As a matter of fact, if you want to just follow your own mind and do whatever you want to do, and just do things that you believe in, it's easy to do, rather than going to someone else's mind and see what he has done, learn it, and compare it with others, and see what you can contribute in it, what is important, and tell the others, okay, this is important, you should pay attention to this, that guy has invented it, and then use it. And actually, this is a very important thing, and my personal opinion that nowadays researchers, many of them, they do not follow this path of research. And by studying his works is a very good lesson. The next thing that I would like to go through details is the computation of the radius of the Earth. If you randomly go to a mathematician or a physicist or if an engineer, a PhD, a faculty member or something, and ask them, okay, do you know how to calculate the radius of an Earth? I would really say that the majority of the scientists today, they have not thought about this problem, and majority of them, they cannot tell you that how to calculate it. They may figure out if they search it Google or they understand it or something, but they have not paid attention to it. And it's not difficult, but it was a brilliant idea by Al-Biruni that he invented it, and he obtained a very accurate estimation. Basically, if you want to calculate the radius of the Earth, you will need a high altitude mountain with a flat horizon, like this mountain that the horizon is flat, and an astrolabe. There's a tool that you can calculate the angles. If you have a high altitude mountain with flat horizon and an astrolabe, then you can yourself you can calculate the Earth's radius. It's translated in Persian. اگه شما بخواید ارتفاعی شعاع زمین رو محاسبه بکنید، شما کافیه که یه استرولبل داشته باشین که یه وسیله هست که بتونید محاسبه بکنید زاویه ها را، و کافیه یه کوه داشته باشین که جلوی این کاملا فلت باشه، درختی چیزی جلوش نباشه، دیدتون کاملا باز باشه. اگه این دو تا وسیله داشته باشین، شما به وضوح میتونید خودتون شخصا، البته به شرطی از اون کوه هم بتونید برید بالا، محاسبه بکنید شعاع زمین رو و استیمیتش بکنید. دقت خیلی خوبی هم داشته باشید. In fact, you need to measure the height of the mountain first. If you want to find the height of the mountain, you only need to go a distance from the mountain, let's say this point, use an astrolabe to calculate this theta, theta 2, and then come here and calculate theta 1. If you calculate theta 2, theta 1, and the distance d, using this formula that Al-Biruni derived, you can calculate the height of the mountain. This is the first step in calculating the Earth's radius. اگه خواستید شعاع زمین رو محاسبه بکنید، کافیه که طی چند مرحله است. یکی از مراحل‌هاش اینه که ارتفاع کوه رو محاسبه کنید. ارتفاع کوه رو میتونید بیان از یه نقطه‌ای مثل اینجا، این زاویه تتا 1 رو محاسبه بکنید با استفاده از استرولبل، بیان اینجا زاویه تتا 2 رو محاسبه بکنید و این فاصله رو هم اندازه بگیرید. تتا 1 و تتا 2 و دی رو که محاسبه بکنید، میتونید بزنید تو این فرمول که البیرونی درایو کرده و با توجه به تیبلی که خودی البیرونی هم محاسبه کرده، میتونید دقیقاً اچ را محاسبه کنید. The next step is to go up on the mountain and calculate the angle alpha in this picture. So basically you have h and you have alpha. So you have all the variables in this formula. So basically using this formula you can compute the radius of the Earth. So basically you calculate from the previous previous formula the height of h, and using an astrolabe to compute alpha. Then using this formula you end up calculating radius of Earth. Indeed, Al-Biruni followed this invention and estimated the ratio, the Earth's radius as about 6,335 kilometers. But the actual precise today's calculation is about 6,371 kilometers. That if you consider as percent, you will find that it is 0.6% error. That is, I would say that is highly accurate in his time. Consider that it belongs to 1,000 years ago, and this is really a precise calculation. Let me see how much time I'm left. There's another problem that is very famous in mathematics, that is trisecting an angle, dividing an arbitrary angle in three angles that are equal, by using an straightedge, ungraded straightedge, and a compass. That is a very famous old problem. In high schools in Iran they teach it. I'm sure that in Bangladeshi or other places they might also teach in high schools. This problem has application in geometric constructions, pattern constructions, in mosque and tiling art. This problem were open until Wonzel, who was discovered that this problem is impossible to solve. He proved that this problem with unmarked straightedge and a compass is impossible. He proved 1800 years after Biruni. But what is interesting is that Al-Biruni, 800 years before Wonzel, knew that this problem is very important. He paid a lot of attention to it. He dedicated a lot of his research on that. He presented 12 different problems that they are actually equivalent to this problem. And I would remind that in even nowadays mathematical works, sometimes some mathematicians, they do mistakes, they publish papers and they claim to have solved something, but basically they have made some wrong assumptions in their research, their papers, and published their works. But the way that he presented 12 different problems and proved that they are equivalent, that means that 1,000 years ago, he knew something that some nowadays researchers in mathematics do not know well. The other thing is that Biruni, basically he was feeling, he didn't prove it at that time, that the problem is impossible to solve. But because the problem was important in applications, in construction of geometric patterns and in architectures and Islamic art tiling, instead of precisely solving that problem, basically he found ways to approximately solving the problem. And in real world problem, if you with high accuracy, not exactly, high accuracy, solve something, and you design a, for example, trisect an angle, but not precisely, but with a high accuracy, this is sufficient for art tiling. So basically, Al-Biruni, in his research, tried to associate it, this problem, finding roots of some polynomials. He wrote a book on calculating, estimating roots of polynomials. That book is now not available, is extinct. But the fact that 1,000 years ago, a researcher wrote a book on estimating the roots of a polynomial, that is really significant. If you go to an engineer, nowadays any scientist, he will see that, he will tell you that in all of his research, he will deal with computing and estimating roots of polynomials. But Al-Biruni, 1,000 years ago, he wrote a book on this subject. That means that he was so brilliant, and I can surely confirm the Gofrov statement that he was ahead of his time, let's say at least 800 years. He presented in his works some principal ideas of many research subjects of today's time. Many subjects are attributed to some people like Poincaré or many well-known mathematicians. But if you dig in on those proofs and the ideas, you will see that some of the original ideas traces back to Al-Biruni's work. And I would dare say that if Al-Biruni would have lived longer, many of the works that, for example, the work that is attributed to Wansel, Biruni would have done it. If he would have lived longer, he would have certainly introduced field extensions or many things that Galois, well-known mathematician, invented. He worked on many things like wheat and chess board problem. You may have heard of it. So basically, he is the first person that solved that problem and interpreted in nowadays daily life expressions, so that regular people, they can understand how the solution and how the big number of wheat would be if you follow the chessboard problem. I skipped many of the points that I had prepared just to shorten the time, and we would get back to the normal schedule after lunch. Any questions, any comments is appreciated.
Thank you, Dr. Gazor, for his wonderful presentation in respect of mathematical points of view and contribution of Al-Biruni in respect of mathematics and special reference to geometry. My specific point of this, Al-Biruni visit to India. He was influenced by the great Indian mathematicians like Aryabhat, Chanakya, Kautilya, etc. So could you please, how impact of Indian mathematics, especially economics or the philosophy, could you have included in your paper, or if it is not, could you please explain it? Thank you very much.
Explain what?
Could you please briefly explain it in respect of the influence of Indian mathematics in the works of Al-Biruni, especially in respect to mathematics? This is my specific question.
To be honest, as I said, I'm not an expert in the history of mathematics or in history, so basically I cannot properly answer this question. But what I know is that Al-Biruni, he tried and learned the works of Iranians, Greeks, and Hindus, and he translated all the mathematical results that Indian, Iranians, and Greeks had in different languages, and he wrote review papers, review articles, review books to summarize all of those. So basically, if someone would have gone and read Al-Biruni's papers, translations, and books, he would have learned all the mathematics that Iranians, Greeks, and Indians had done, and Al-Biruni taught them as an important contribution. He asked that, what do you think that the most important aspect of Al-Biruni's mathematical work? The most important thing that is my personal opinion is the fact that he was following the ethics of research. He was an ethical researcher. He was really fair in his criticism, very frank, and he was never using someone else's work without proper attribution of the work to others. He had cited many works from different nationalities, different researchers, that if he was not to mention those names, nobody knew many of them, or nobody knew that, oh, this contribution belongs to that guy from that country or from that place. He was really dedicated himself, and this is important, and unfortunately, many scientists, they do not follow the ethics.
His work and Al-Biruni was greatly influenced by the Indian mathematician.
Yeah.
That is my specific question.
As I'm saying, I'm not an expert in history of mathematics. So precisely, I do not know which parts of his contribution used from Indians, which I do not know that your precise answer. But what I know that he used all mathematical works that existed at that time. He tried to learn them. This is something that nowadays researchers need to learn to do it. If I want to do research, those work to others.
Thank you very much, Dr. Majid Gazor, for his valuable speeches.